Welcome to EDU World Space.
In this question, we are trying to find the wavelength of a neutron of mass 1.67 times 10 to the minus 27 kilograms, traveling at a speed of 8.5 times 10 to the 4 meters per second. So to answer this question and find the wavelength, I'm going to use de Broglie's wavelength, or de Broglie, however you want to pronounce the name. And that is that lambda is equal to h, which is Planck's constant, divided by momentum, p. So remind ourselves that momentum, p, is equal to mass times velocity. For we can just input that in here and we get that h over mv is equal to lambda. And that is why I'm using de Broglie's wavelength, because mass and velocity is what we've been given in the question, and h is a constant. So we have all the variables we need in this equation to calculate lambda. So let's remind ourselves that Planck's constant is 6.63 times 10 to the minus 34. Now you should either know that or have it written in your notes. That's not something a question will usually give you. The mass we are given is 1.67 times 10 to the minus 27. And we don't need to change the units here, as we've been given the mass in the SI units of kilograms, and times that by the velocity, 8.5 times 10 to the 4. And if we put that into a calculator, we get that the wavelength comes out as 4.7 or 4.67, but I'm using two significant figures here, times 10 to the minus 12 meters. Now the convention with wavelengths is that we usually give wavelengths in nanometers. So I'm just going to convert that answer to nanometers. So we know that nanometers are times 10 to the minus 9. The prefix nano is times 10 to the minus 9. So if we're taking times 10 to the minus 9 power away from this times 10 to the minus 12, we're left with times 10 to the minus 3. And that is because if we have minus 3 minus 9, we get minus 12. So our answer is 4.7 times 10 to the minus 3 nanometers. And that's just keeping with our unit convention. But this answer is also correct.